on negative exponents. So this time we are going to have exponents around our division with a negative exponent on the outside. Remember what we repeated after me yesterday. A negative exponent does not mean a negative number. So before I do anything, I'm going to put some stuff up here. If this is raised to the negative first and you distribute this, you have 2 to the negative a squared times negative 1, which is 2 to the negative a to the negative second. You guys see that?
Yeah, sure.
Therefore, what is 2 to the negative 1? Please do not tell me negative 2, because that is wrong.
Negative 4.
No!
Negative 1.
Stop.
It said negative
Stop.
1.
A negative exponent does not mean a negative number. 2 is not turning to a negative number. It means a... So this is moving to the... Thank you. And then this would be a over a squared, so this is 1 over 2a squared. Do we all understand what I just said to you today?
Yes.
That is not negative 2. That is 1 over 2.
1/2.
True, same thing. Yeah, I'm very passionate, and I'm very passionate about that not being a negative number. Okay, so...
Come on, man, it took me a long time to pick that up.
I don't want to. I need a seat transfer as soon as possible.
What?
You're here.
Just leave
I think you were playing with it and it just stuck up. All right. A negative exponent rule says, please listen.
Listening.
Anything to a negative power is a reciprocal. So that is 1 over x, or if it's 1 over x, it becomes x. The zero exponent rule tells us anything to the 0 power is 1. The product rule tells us when you multiply, you add the exponents. Quotient rule tells us when you divide, you subtract the exponents. And the power rule tells us when it's a power to a power, we multiply. So all the rules that we've been learning are right there in the front. Do you understand me?
Sure.
Okay, so let's get started. Start with these ones like we did yesterday. I haven't even written anything down yet. RC, help me with that first problem there. What would you do first? So we're going to multiply negative 3 times 5. What else am I going to do, RC?
Add or put x and 2 plus negative 7.
Good. And then what else?
Y, negative 3 plus 1.
Thank you for saying that's 1. Don't. This is why you can't sit next to people. I feel like you should. I've had to say this to you multiple times about.
I did one thing.
No, that's not even. Okay, negative 3 times 5. Oh. Negative 3 times 5 is what?
15.
Negative 15. 2 plus negative 7 is negative 5. And then we have y to the... So, RC, is that my final answer?
No.
So what is my answer, RC? Okay, but the exponents, when you reciprocate them...
Say that other payment rule.
Huh? You don't put the negative. Remember, the reciprocal allows you to change those to a positive. That is what the reciprocal does. All right. Josh, help me with the one right next to it. 6x to the negative third, y squared over 9xy to the negative fourth. What do you do first?
That's like
You got this, Judge.
You are going to...
Yeah, so what's the exponent on the x in the denominator? So it's x, negative 3 minus 1, good. And then what's the next one there? 2 minus a negative 4. What do you do with the numbers, though? What goes into both 6 and 9? So we divide top and bottom by 3. So that is 2 over 3. So then we simplify some more. So I have 2/3 x to the negative 4th. 2 negatives become a, so y to the 6th power. So Josh, what do I have to do still to get my final answer?
Oh, you have to get rid of the negative 4.
So how are you going to do that?
Oh, don't you have maybe a fraction?
Yeah, so it moves to the, it's in the numerator, so it's going to move to the, so we move that down, right? Does anything else move besides that?
No.
No, because we have a 1 exponent on these ones, so they're positive, so they're fine where they are. So we're 2y to the 6th over 3x to the 4th. Yes.
So, why don't you, instead of, like how you found out what goes in the both 6 and 9, why didn't you just subtract 6, like how you subtract everything else?
Okay, so those are coefficients, which are the big numbers. These are exponents, which are the smaller numbers. So coefficients will follow those same rules. Those big numbers follow the same rules you've always done. So if you've done 9 divided by 3 in the past, you've gotten 3. You haven't subtracted them, right? Now, exponents are different. These are called exponent rules because we're doing them with the exponent. So 6 and 9 are not exponents. So that's why you don't subtract them. Does that make sense? Justin, can you help me with that? 2x to the negative 4th, y to the negative 1? Yeah.
Well, you gotta see what goes for both of them.
Which is? So I divide top and bottom by 2, and I don't like my negative in the denominator, so I move it up. If you didn't move it, I wouldn't mark it wrong. Okay, then what?
You gotta subtract 2 x's,
Which is what?
0.
No, it's not. Negative 4,
Minus 4.
which is not 0.
Negative
There you go. And then what else do you have to subtract?
8. Negative 3.
So y to the negative 1 minus a negative 3.
2.
Yes, that is 2. Very good. So we get negative 1 over 2 x to the negative 8th. 2 negatives make a positive, and as Justin said, that's y squared. So, Justin, what do I still have to do here? What is that? So, what do you get then? Well, what's in the numerator? Okay, and what's in the denominator? X to the 8th. Good. Connor, help me with that last one on the slide.
Make the 6 go into.
And what do you do with a power to a power?
Multiply.
Okay, so I'll do negative 2 times 6 and 3 times 6. What else do I have to do?
You have to make the 2 on the y.
And what do you do when you do a power to a power?
You multiply.
Okay. Okay, am I done?
No.
What do I have to do now?
Y negative 12. Make it not negative.
We could do that, or we could use the product rule. Do you see how we have 2 y's here?
Oh, yeah.
So what do we do with the product rule? What does that tell you to do? When you multiply, you...
No, add.
So we have y to the negative 12 plus 6. What you said is also a possibility. We could also have done that. Okay, so now what do we have to do, Connor, to get our final answer?
I'll make y on the negative.
Okay, so tell me the final answer.
Z to the 18th power over with the y to the 6th.
Okay, look at those first 4 before we start distributing negative exponents into our parentheses. Okay, I'm going to repeat myself. Ready, guys? This is going to happen again. So when I give this 2, I get 16. I'm going to change that 16 so it's not such a large number. We're going to make that 6 instead. Okay, so when I do this, I get 6 to the negative second, because there's a 1 on it, 3x to the negative 6. Yeah, it's Miss Brown down the hall. We're doing a baby shower for her after school. Anyways, so
I ain't got my size
what does 6 to the negative second mean you're doing?
6
What does the negative exponent mean?
times.
So we move that. So this is 1 over 6 squared. And this is 1 over x to the 6th. Do you guys see that?
Yes.
What is 6 squared?
36.
So this means 1 over 36, x to the 6th. Do you guys all understand that a negative exponent does not mean a negative number? This is the second time I've done this, and I will continue to drill this into your heads. You guys have a quiz. You're right. It does. I didn't mean it like that. You guys have a quiz on Friday that we need to make sure you're understanding everything for. I'm going to do it with this problem here. Okay. So remember, these both have exponents of 1. So we give the exponent of negative 2 to them. An exponent to an exponent means you. So we have 4 to the negative second and x to the negative second. A negative exponent does not mean a negative number. Riley, what does that mean we need to do here?
You gotta make it a fraction.
Okay, so what is that fraction going to be?
Wouldn't the exponents negative 2 and negative 2 go on the bottom?
They would both move to the bottom, so what would we have in the bottom?
Or 4 to the second power and
Times.
Times x to the second power.
And what's in the numerator if there's nothing left? 1. We put a 1 there. What's 4 squared, guys?
16.
So we have 1 over 16x squared. So notice, did I make that 4 negative at any point? No, a negative exponent is not like multiplying by negative 1. A negative exponent means a reciprocal. Justin, I see what you're doing. You might want to put that away now. Okay, we have a 1 on the 3. So we give this to everything. When you do an exponent to an exponent, you multiply. So I have 3 to the 1 times negative 2, x to the negative 2 times negative 2, and y to the 5 times negative 2. So I have 3 to the negative second, x to the positive 4th, y to the negative 10th. Jordan. Childs. Did I say that right this time? Yeah. What does that mean it's going to do here? Okay, what's going to stay in the numerator for this one?
I think I got it. I got it.
The x to the 4th is the only thing in the numerator. What's in the denominator?
3 to the second and y to the 10th.
Perfect. So what's 3 squared?
9.
So we have x to the 4th over 9y to the 10th. I put that in a really weird location. What are the exponents on the 2 and the 3? What are the exponents on the 2 and the 3?
1.
So we give the exponent to both of those. So we have 2 to the 1 times negative 2 over 3 to the 1 times negative 2, which is 2 to the negative second over 3 to the negative second. So Alyssa, what does that mean for us? Which means that it is what over what? But what exponent did you forget? 3 squared is?
9.
Oh, so then why it's switching goals?
2 squared is? So, if it starts in the numerator, it moves to the denominator if it's negative. If it starts in the denominator and is negative, it moves up to the numerator, so that's why those ones both switch. Do you guys see that? You always keep things improper. You guys need to get away from the mixed numbers. It's weird because like when you're in middle school, it's like that's all they want you guys to use, and then you get to high school and we only want you to use improper. So it's just like unlearning that stuff. It's not bad to understand what the improper fraction is because then you know like about how big that is, but just for our cases it makes more sense that way. Okay, what are the exponents on 3 and 5?
1.
Okay, so we give this exponent to both of those. So we have 3 to the 1 times negative 3 over 5 to the 1 times negative 3. So that's 3 to the negative third over 5 to the negative third. So Mike, what does that mean we need to do?
Put it in a fraction.
Well, it's in a fraction already. What would it turn into?
You put 1 on top and then the rest on top.
Okay, which one? Let's be more specific.
They both would be.
Okay, so what does it become? Just tell me exactly what it becomes.
Put the 1 on top.
It would not be 1 on top. Then
I'll just switch it.
the negative 3 moves it down. This negative 3 moves it up. So what would we have here? 5 to the
Cube.
and over.
3.
There you go. 5 cubed is 125. 3 cubed is 27. All right. Do we have questions on those before we do some more problems?
Wait, why is cube 3?
What?
Why is cube 3? Cube.
Because they're 3 dimensions. Cubing something is like 3 dimensions.
What's 4? If
Four.
it's 2
Quad?
squared, is 3's.
Oh no, I just think of quad.
Also, if you...
I know it's cube.
There's also,
I
like,
was
when
just
you guys
wondering
start
why.
talking about things, like...
I was just wondering why it was the
In
same.
Algebra 2, there's different regressions and stuff is what it's called. So linears have a constant first difference, which means that you have a constant slope. Quadratics, which are squared, have a constant second difference, so that's why they're squared, which means that if you were to subtract all the y values, the first difference is not the same, but if you subtracted all those values again, they have a constant rate of change the second time. So it has to do with a lot of different things, too, in math. Like, there's different things you can look at. Yeah.
Can I use the restroom?
No, because we're about to get to some challenge here. Okay. I'm not even like joking when I say this. Okay, phones are going to be collected the next time I see one. I've seen a few of you with phones, and I'm not okay with it. If you're touching it,
I don't even have my phone.
I don't care. All right. That gives you something that I can't take then. Okay, so we give this 2 to everything. A power to a power means you. Don't forget that if it doesn't have an exponent, it has an exponent of 1. So we have 2 to the first times 2, x to the second times 2, y to the negative second times 2, 3 to the first times 2, x to the seventh times 2, and y to the first times 2. I will look at that and see what you can see. I'm not going to move on yet. A lot of you guys do. I don't know if any of you show this work on your homework, and if you do, that's fine. But I think most of you skip this step on your homework. I think most of you just do the multiplication.
Yeah.
I do this in the notes so you know. I do this in the notes just to make sure you guys, if you were to look at these, you know what I did. So we get 2 to the second, x to the fourth, y to the negative fourth, 3 to the second, x to the 14th, and y to the second. When you divide, what do we do with the exponents? So we know 2 squared is 4, so I'm going to rewrite that. I'm going to subtract my exponent, so that's x to the 4th minus 14, y to the negative 4th minus 2. 3 squared is, so there's a 9 in the denominator. There's not a lot of space here, so.
My math's not clear.
Okay, so we have 4x to the negative 10th, y to the negative 6th over 9. Okay, before I move on, I want to make sure that we all are okay with what I have so far and we don't have any questions so far. Do we have any questions so far about how I got anything up there? Following this nice pattern here.
So
He called me by my name. Go ahead.
So for when it says 2 to 0 power x, so 4 power 1 to the negative 4th power, can you just subtract the bottom by the top?
I always do numerator minus denominator. It's so that it ends up in the numerator.
I was just wondering if you could do it the other way.
You could, but then it would need to end in the denominator. Opposed to that. So whichever one you subtract first, you need to put in that spot. Okay, so Emma, what is my final answer then? What is in the numerator?
Why are you doing this?
Wouldn't 2 stay there? Yeah, 2 and x would stay, right?
We're here.
Oh. 4 would stay, right?
Okay, and then what's in the denominator?
X to the 10 and y
What else should be in there? The 9 does not move, right? And we always put the numbers in the front. Okay, questions on that one? Next one. That's good. So this x to the negative 1/2 goes into this one. So an exponent to an exponent means you. And whoever threw that needs to pick that up. So -6, half of -6 is 2 negatives make a positive, so half of 6 is 3. A negative and a positive is a negative. Half of 4 is good. Half of 2 is, so that would be -1. One's negative and one's positive. And then half of 4 is, okay. When we do division, we do what with the exponents?
Subtract.
So it's 3 minus a -1 and -2 minus a -2. 2 negatives make a. So I have x to the 4th, y to the 0. What's anything to the 0 power? 1. So this is just x to the 4th. Be nice. Okay. Questions? Shh. I'm going to stop again. I want to make sure you're understanding each one of these steps following these crazy arrows. Are we understanding things?
I understand it, but that's way too many numbers.
And it's like, go here, then come down here. Wait, let's go back up here and swoop down here. I wish I could
Let me go up here just so I can go back down, just so I can go back up.
Right, it's a roller coaster ride of numbers here. Okay, what is the number? What is the exponent on 6 and 9? It will be -3. So we give the -3 to everything in the numerator denominator. So I have 6 to the 1st times -3, x to the 1 times -3, y to the -6 times -3, all over 9 times 1, or to the 1st times -3, -1 times -3, and y to the 3rd times -3. So go ahead and get that all written down, because I go faster in that part, so I'm sorry.
It is easier than it looks.
I think if you're understanding it, I hope it's easier than it looks. I just never know.
It's ridiculous. Big number.
It's not even big numbers.
There's just lots of them.
Stop talking about the slither.
So we have 6 to the -3rd, does not mean -6. X to the -3rd, y to the +18th, 9 to the -3rd, -6 times -3. Who asked that question? Oh, you did. Exponent to an exponent means you multiply. -6 times -3. X to the 3rd, y to the -9th. Okay, we have to be careful. These two mean that we have to do what with them, with these negative exponents? Flip them. So 9 goes to the numerator and 6 goes to the denominator. An exponent, when we divide, so -3 minus 3 and 18 minus a -3. 9. Connor? Not right now, okay. Unless you have to go, like it's an emergency. Huh? Bingo, you're fine.
Good.
9 to the third power is
27.
729. Wait.
729. Yeah, 729.
I don't know why there's so much talking going on. I cannot even think. Stop playing with your water bottle. Stop. 18 plus 9 is 27. 6 to the third is 200 and what?
16.
So can you do 729 divided by 216 and get a whole number or no?
No. It's 3.379.
Okay. So what is that as a fraction? What is 3.375 as a fraction? Do you know how to switch that in your calculators?
3 and 3
Press the button.
As an improper fraction?
Well, as an
What is it?
27 over.
So it's 27 over 8. So 27's on top, 8 is on bottom. Okay, what is in the numerator? What else is in the numerator with 27? Y to the 27th. What is in the denominator? You guys are stressing me out because you're talking so much. Okay, so this is not easy, and that's why it's stressing me out. Are we all actually doing okay with this?
I am.
If you are not, please make sure you're asking questions, all right? Because sometimes this can be overwhelming with all the stuff we've been doing and all the steps and stuff. Once you get it down, I mean, I can look at some of these and do like part of it in my head and just write that part down sometimes, or all of it. You know what I mean? Like once you get good at it, you'll probably be able to do a good portion of it in your head. Okay? All right, so when we do this one, what is the exponent on the y in the denominator? Good. So we distribute that 1/3 to everything. So I have x to the 5th times 1/3, y to the 4th times 1/3, and we keep everything as improper fractions while we're multiplying these. Don't write them as mixed numbers, please. So what is 5 times 1/3? What is 4 times 1/3? What is 2 times 1/3? I think that's what they say. I can't even read my own handwriting. And then 1 times 1/3 is just. Okay, what do we do with the exponents? We have 5/3 minus 2/3 and 4/3 minus 1/3. Which moves down to x1, y1, which is just xy. Ready for those challenge problems?
No.
I am.
We do.
XY.
The answer to that question is x times y. You simplified that to x times y.
That thing right there.
Yeah.
Out of all that multiplication.
Yep. It's just x times y. Yep. You're going to love the practice problems I created for you guys on the computer today. You are going to hate me after today.
That's all.
I'm just ready for you guys to yell at
I
me.
just drank 2 water bottles and it's not going to.
I just have to use the brush.
All right, challenge problems. Here we go. So challenge problems. So here we go. What do we have to do first? Multiply the exponents, which means, Colin, what are we doing?
We're going to multiply, let's see. So we're going to have, let's see, okay. I already started this one. -2 to the -4th power
Okay.
times n to the -16th power.
I'm not going to show the in-between steps on this one.
Okay, and then n to the 52nd power.
Oh, that's beautiful.
And then p to the -52nd power.
Okay. Over.
All over 8 to the -4th power.
Stuck my head.
M to the -8th power.
Okay.
N to the -28th power.
Perfect.
And p to the 32nd power.
Is that all?
Yes, that is all. For the first step. Then.
No, just 1 second. We're going to pause there. Questions on how any of that became? No.
I think you love
You dropped something.
Hey, those keep turning off, those two.
Oh my gosh.
Dang it.
Okay.
That one and
It's
that
fine.
one keep turning off.
They're just going to sleep. All right. So, a negative exponent. First of all, these should be in parentheses just so we get used to that. What does a negative exponent mean? We're going to do with these two numbers. We are going to flip those two numbers. So we have 8 to the 4th over negative 2 to the 4th. Okay. Tanari, when we divide, what do we do with those exponents?
Exponents?
Yep. Okay, I'm going to write this out just so we don't do it wrong. So that's negative 16 minus a negative 8. 52 minus a negative 28. And negative 52 minus 32. What?
Why wouldn't you bring the negative 16 down since there's...
You could. So there's different ways you could do this. I'm just trying to do it the same way every single time that I've taught it so that you guys don't get confused. Because there's like so many different ways you can do exponent rules, and I just want to do it that way. But you can always switch negative exponents first if you want to.
Sure.
Okay? Which might be how Stein does it. It does not matter. I just try to do the same thing every time so I'm not confusing people. 8 to the 4th power. What is 8 to the 4th power?
4,096.
What is negative 2 to the 4th power?
Negative 16.
Ah! You have 4 negatives.
Oh, positive 16.
But it isn't 6. Yes, it is. So you have 4 negatives, so they have partners, right? So there's no more negatives, so that is just 16. So we have m to the negative 8th. Oh my gosh, so that's 10, carry the 1. Is that n to the 80th?
Yes.
And p to the negative 84th?
Yes.
Woo, what's 496 divided by 16?
256.
So that's just 256 in the numerator. What else is in the numerator with 256?
M to the 8 to the 8.
8. M is to the negative 8.
Oh, yeah, sorry, I thought we were doing the denominator.
What's in the numerator? What else is in the numerator?
M to the 80th.
Glad that you guys are paying attention right now.
Already did the problem.
What else is in the denominator?
It's P to 84.
Okay, how many of you did that on your own and were able to get that answer? Good job. Doing good? Just kidding.
I got 256 and into the
We're going to do the other one too.
into the 8. The P is the only one I didn't get.
Can we try
That's
the second
good.
one
I got
by itself?
No, Colin? No.
Go ahead. I'll give you guys 5 minutes to try it. I'm not going to come around and check it, but I will do that. So try the second one by yourself real quick. I just want to see if you can do it. What?
Wouldn't the P be on top? That's what I'm saying.
Because it's positive.
No, it's P is to the negative 84. Because you're doing negative 52 minus 32, which makes it more negative. Do you see that now? Do you see it, Alyssa, why it's there?
What?
Why it's on the bottom?
No, man.
That's great. Now do it on your own.
I need a teacher. And never put me next to Ryan.
Oh my gosh.
Please, Miss Brady.
At 11:33, I'm going to start going over the problems. You have 3 minutes.
I don't know what I'm doing.
Distribute those exponents in first. And remember, a power to a power means to multiply. So distribute those exponents to everything. C has an exponent of
1.
Yep, so distribute both exponents in.
Shut up.
I get two.
That was my one.
They're 2 different ones.
Oh, I should go.
You should do it on the board.
If you're not trying, you're just hurting yourself. So it's your choice what you want to do. If you have questions for me, I am wandering around right now. But I told you, give that exponent to all the other exponents. Power to a power means you multiply. So that's my hint to you.
Does B have an exponent? No.
B does, yeah, B and C both have an exponent of 1.
No, C has an exponent of -4.
This one does, but this C has one of.
You're not going to start all over.
Did I win the bet?
that's not over yet. This class period is not even over.
Problems like Stein gave us the one, like for normal.
I know.
They
But it
stretch
makes it easier to do the other problems. So.
out. Great. So good idea on the problem.
Mike, you should be doing the problem. Not when you first subtract, no. And then you're. So what I would do before you make it a fraction is distribute this 1/2 in and do the product rule. Okay. As your answer?
Yeah, that's my answer.
Okay, I haven't gotten the answer yet, so just 1 second. So that is
I don't think
6
it's
times
right.
2 is 12. Half of that is 2. Well, no, because A should be to like a bigger power. What did you do when you subtract? You subtracted 4. You would subtract a negative 4. That's why. This is a negative 4. Do you see that? So you do 8 minus a negative 4.
So would it be 12?
Mm-hmm. So that would be 12.
Oh.
Let me try the next one with you. I haven't looked at the other numbers. I just started with 12. I would change it to minus a negative though. Okay. And then your B, you do the second, and you're adding 3. Negative
I would like to see transfer.
Yes. You got a different than Rockies too.
You forgot to give the 2
Somebody
there.
kill
You
me.
see that? Because it has an exponent of 1. Remember, they have exponents of 1 if they're not there. Are you forgetting that?
Miss Brady,
What?
can I have a C transfer?
All of you want C transfers. I'm gonna change seats. Don't worry. All right, guys, I'm going to go over this, so please just stop. So, here's what this is going to be. A few things that I saw, and you're not making big mistakes, so please listen to me and look at me. I want everybody to look at me.
Hello.
Please look at me, everyone. You are not making big mistakes. You guys are doing awesome. Do you understand me? I am so impressed with you guys. I don't want you guys to feel bad about yourself if you can't do this problem. This is a challenging problem. It will not be like this on the quiz. This is way harder than what the quiz is. Do you understand me? Do we all understand that? I want you to know that I'm very proud of those of you that are putting in the effort. You're trying and you're getting these. You're understanding what it's saying. You understand? You're making little mistakes. Okay, so we give the 2 to everything. A power to a power means we multiply. We give the exponent here, so we have a to the second, b to the negative third, c to the negative first. Do we all see that?
Yes.
So now I'm going to do my quotient rule, which tells me to subtract. So that's 8 minus a negative 4. B doesn't have anything. Negative 8 minus 2. Be careful when there's a negative in the denominator. 2 negatives make it positive.
Ready, when?
46.
No, yeah, another 35.
Because we take notes almost every single day in this class. It's insane.
You don't throw away your notes.
Okay.
That's just one side.
So the product rule tells us to add the exponents. So I'm going to add anything that has like exponents here. So I get a to the 14th, b to the negative 1, c to the negative 11th. So your final answer is a to the 14th over b, c to the 11th. Did anybody get that?
I didn't get that far.
I did not get that.
I didn't either.